A current of 5 ampere flows through an electric press of resistance calculate the energy consumed by press in 5 minutes. So solution of this question: W is equal to I square RT. At the place of I, write 5 ampere. R is 44 ohm and T is equal to 5 into 60 second. So substitute the value 5 square into 44 into 300. So unit of work done is joule. Multiply now. 3.3 into 10 to the power 5 joule. Any doubt?
No, sir.
If you have written, you tell me. I will go for the next question.
Yes, sir, written. Sir, written.
Good. Next question. A set of n identical resistors, each of resistance R ohm, when connected in series, have an effective resistance X. And when the resistor are connected in parallel, their effective resistance is Y ohm. Find the relation between R, X and Y. Let us check solution. When they are connected in series, it will
Sir,
be
but
R.
you have written when the
I should read again. A set of identical resistors. This word is identical.
okay, sir. Sir, you said you will read the question.
Yes, a set of identical resistors, each of resistance R ohm, when connected in series, have an effective resistance X ohm. And when the resistors are connected in parallel, their effective resistance is Y ohm. Find the relation between R, X, and Y. Have you written?
No, sir. Find the relation. Yes, sir, written. Sir, written.
Good. Am I audible to you? Can you hear me? Let us see the solution of this question. X is equal to R plus R plus R. There will be n terms.
Sir, your screen is not still showing.
Just now what you can see.
Sir, it is just showing that it is connecting, but it has not connected yet.
Now,
So, blank screen?
okay. Now also.
No, sir. Yes, sir.
It has come now?
Yes, sir. R plus R N.
Oh, yeah, right.
Yes, sir.
When connected in parallel, we have till n terms, this will become n by r. Therefore, y is equal to r by n. This is first equation. This one is second equation. Multiplying 1 and 2, do the multiplication. X into 1 upon y, x into y, this is equal to, you write nr multiplied by r by n. N cancel. You will be getting r square is equal to xy. Any problem today?
No, sir.
So this solution is over. Have you understood?
Yes, sir.
Okay. You are using earphone.
Yes, sir.
Hmm. The sound quality is good with earphone.
Sir, what? Yes, sir.
I should go for next question.
Yes, sir.
Your question is, An electric bulb is marked 100 watt, 230 volt. If the supply voltage drops, what will be the total heat? And light energy liberated by the bulb in 20 minutes. You see the formula, the power of an P of an electric bulb, P is equal to V square divided by R. So what will be R? V square divided by P. Substitute the value 230 volt into 230 volt. Power is how much? So this much you will be getting as 25 watt. Am I audible to you?
Yes, sir.
So
Sir, Sakshi has not joined.
no, might be internet issue. Here you will be writing value of P is 100 watt. Write here 100 watt. So 0 cancel. It will be 529 ohm. If the voltage drops to V dash, then the power consumed will be P dash is equal to V dash square divided by R. Substitute the value. We'll write here 115 volt into 115 volt. And resistance is 529. This can be written as 115 into 115 divided by 23 into 23. 23 5 ja and then 23 5 ja. So 5 5 ja 25 watt. Energy liberated in 20 minutes we have to calculate. The energy liberated in 20 minutes. W is equal to P dash into T. P dash will be 25 watt into 12 5 ja 60. 12 2 is 24 plus 6, 30. 300 multiplied by 2 more zeros. So this is equal to 3 into 10 to the power 4 joule. Do you have any kind of problem?
No, sir.
Written?
Yes, sir.
Let us see next question.
Sir, will you teach tomorrow?
You don't want to study tomorrow?
No, sir, it's not like that. I want to see. At morning at 11, my physics exam is there, and at 3:20 to 4:15, my English exam is there.
Okay, so after that you'll be free, no?
Yes, sir. At 8?
Oh, in morning you are free? Yeah.
No, sir.
Late night you study, at 8 you study.
Okay, sir.
I have to write question, no? An electric bulb rated for an electric bulb rated for 500 watt and 100 volt is connected in a circuit having a 200 volt supply. How much resistance should be put in series? With the bulb so that the bulb delivers 500 watt. This is the problem. Am I audible to you? Are you able to hear
Yes,
me?
sir, but your voice was lost in between.
Connection
Yes,
was
sir, but your
disturbed.
voice was again lost in between. Okay.
Connection was disturbed at that time. So I again
Yes, and now also your voice is kind of vibrating.
now it is clear.
Yes, sir, in between it is
Okay.
something like vibrating.
So let us see the solution of this question. First we'll find the resistance of the filament of bulb. Resistance of the filament of the bulb. Sachi, am I audible to you? You know the formula? R is equal to V square divided by P.
Yes, sir.
So at the place of V write 100 into 100 volt. Power is 500 volt. These two zero you cancel. It will go 20 times. 20 ohm. Any problem? Next part, the maximum current
No, sir.
allowed through filament of bulb. This I is equal to P divided by V. So at the place of P, write 500 watt and your V is 100 volt. Cancel these two. This is your 5 ampere. Any problem?
No, sir.
Have you done this much?
Yes, sir, I have done.
Next part you should see. Let R dash be the resistance to be put in series with the bulb when connected to 200 volt supply. So what is the formula? I is equal to V upon R plus R dash. So I you write 5 ampere. V will be your 200 volt, small r plus R dash. Substitute the value 200 volt divided by your R will become 20 ohm plus R dash. Now do the cross multiplication. 20 ohm plus R dash, this is equal to 200 divided by 5. That is 40. R dash is equal to 40 minus 20. We'll be getting 20. Have you followed it?
Yes, sir.
Your solution is over.
Yes, sir.
Have you understood?
Yes, sir. Sakshi has gone.
Internet problem might be there. She will not be able to study, I think, in this way. She came for
Yes, sir.
10 minutes. During last 10 minutes, she was there. You solve this question.
So now your voice is also vibrating.
Is it coming now? Now you are
No,
able.
sir, like piano it is coming.
Oh, internet connection is unstable. It is.
No, sir.
No. I should take you on call.
Sir, please speak again.
I should take you on call.
Sir, it is coming.
Coming, then it's okay. You solve this question. Electric power of from a 100 megawatt power station from is to be transmitted to a distant load through long and thin cables. Should it be transmitted at 20,000 volt or at 200 volt to minimize power wastage? Have you understood the question? Solve it. Are you facing trouble?
No, sir, I'm trying. So what is the answer?
20,000 volt transmission.
So mine is coming 40,000.
Okay. So let me solve it and then you see it. Power is equal to 100 megawatt. So you write it
Yes.
100 into 10 to the power 6 watt. Let R be the resistance of the cable. So find how much current is going. I1 is equal to P upon V. So 100 into 10 to the power 6. Suppose you transmit 20,000. So these 40 will cancel, 20 from here, 20 from here. So it will become 5 into 10 to the power 3 ampere. And the current at 200 volt transmission. I2 is equal to 100 into 10 to the power 6 divided by 200. So it will come 5 multiplied by 10 to the power 5 ampere. Are you following it?
Yes, sir.
Next thing we'll calculate how much power dissipation will take place. So P is equal to I1 square into R. So I1 is in first condition is 5 into 10 to the power 3 whole square into R. So it will be 25 into 10 to the power 6 into R watt. Calculate in second condition. P2 is equal to I2 square R. I2 is your 5 into 10 to the power 5 whole square and R will be R only. So 5 into 10 to the power 5, it will become 25 into 10 to the power 10 into R. So which one is more, you see? This is more, no?
So above one.
Down one,
Below one.
below one.
Yes, sir. I
So,
understand.
so you
Yes.
should transmit at this, and this result is coming in 20,000 volt. So we should transmit at it's clear.
Yes, sir.
Combination of resistances formula we have derived or not?
Sir, no, sir. I haven't did any derivation of this chapter. I was doing the previous one
Okay, okay.
because my exam is coming.
Wait few seconds. Are you there? Sazia, are you there?
Absolutely.
Am I audible to you?
Yes.
Write this problem.
So which problem?
The maximum power rating of 20 ohm resistor is 2 kilowatt.
So pardon, the maximum.
Power rating of 20 ohm resistor is 2 kilowatt.
The maximum power rating of.
A 20 ohm resistor is 2 kilowatt.
Sorry, your voice is vibrating. I can't hear you.
Okay. You mute the Zoom.
And my board is ICSC. ISC.
Am I audible to you? Am I audible to you? Hmm? Hmm. Am I audible to you? अच्छा वो भी काम करता है उसमें आपकी आवाज नहीं सुनाई दी Are you able to hear me? Okay. Write this question. The maximum power rating of 20 ohm resistor is 2 kilowatt. Written? Can you safely use this resistor across a 300 volt DC source of negligible internal resistance? Can you safely use this? Okay. Can you safely use safely use this register across a 300 volt DC source of negligible internal resistance. Resistance. You see on the screen now. R is equal to 20 ohm and power maximum is equal to. My sound is coming to you, no? 2 kilowatt. If the resistor is connected, if the resistor is connected to a 3 volt DC source, 300 volt DC source, power dispatched at energy is equal to V square by R. So at the place of V, you write 300 into 300. Resistance is how much? 20. You'll get 4500 watt. That is 4.5 kilowatt. This is more than 2 kilowatt. Hence, this resistor will melt if connected to a 300 volt DC source. Do you have any kind of problem? You have understood it? I should change the page. Next question. A voltage of 30 volt, a voltage of 30 volt is applied across a color coded carbon resistor. With first, second, and third rings of blue, of blue, black, and yellow colors. Find the current in the resistor. So R is equal to 60 multiplied by 10 to the power 4 ohm and V is equal to 30 volt. Now you can complete. Use this formula and complete it. Good, very good. I hope you have understood this question. So tomorrow at 8 p.m. No? So we will study for. Do you have book? Physics book you have? Okay, no problem. I'm telling you. There is a topic, color code of register. It is on in my book on page number 233. I am also having Newton ISA physics 33. You open this electric resistance and Ohm's law. Color code of resistors. See, this one table has been made, no? Color black, brown, red, orange. So you'll apply the concept from here. Like here, color code carbon resistor with first, second, and third ring. Black, black, yes. Blue, black, and yellow. So blue is 6, black is 0, yellow is 4. So you're taking 60 to the power 60 into 10 to the power 4.